Alright, thank you for joining me. We're going to do a quick tutorial here on how to graph polygons in the coordinate plane. Before we get too far into it, let's just remind you of a few things you may have forgotten. First of all, what's a polygon? Well, a polygon is exactly what you see here. Any shape you're probably very familiar with, like rectangles, pentagons, triangles, any enclosed figure. And of course, then what's the coordinate plane? Well, the coordinate plane is what you graph two dimensions on, x's and y's. So x and y axis. We call it plotting points. So we're going to actually take some points today and we're going to plot them on a coordinate plane to see what figures we can create. So we're going to start here and plot starting with A, and just a reminder, when you're plotting points you always move along the x-axis first and then the y-axis. So the first coordinate that you see here on point A is the x, and the second point is your y, and that's going to remain consistent throughout this tutorial. So for -4, that means we're going to move to the left -5 places and then down from there 4 places, which would put us right about there. Alright, and I'm going to go ahead and label that A. And for the next point, same thing. First coordinate's x, second coordinate y, -3, 2. So left 3, up 2. And we'll plot that point. Okay, then we'll label that B. And C is going to be -5, 2. So that means -5, go left 5, and up 2. That's going to be C. And finally, let me close in that B a little bit. There we go. The last point, -3, -4 means to go left 3 and down 4. All right. On this next example, it's going to be exactly like the last one, except for this time you'll notice that they have left out one of the points, or we don't really know that yet, but you're going to find that out. I can tell though because it says find the distance from points A to D and the distance between A to B. Well, if you'll notice, they don't give us a point D. That means they just want us to go and find it. So to do that, we're going to start plotting the other points to see where it would lie. So we're going to start with A, -3, 4, which means go to the left 3 and up 4. Alright, we'll mark that A. And then for B, we're going to go to the left 3 and down 2. Left 3, down 2. And that is B. All right. C is going to be 2, -2. Right 2, down 2. All right. And at this point, this is where they're trying to see if you can determine where the fourth point would go. Well, it looks like we're creating some type of rectangle. All right. And if you just simply start at point C and move directly vertical up, up, up until you reach where A would be horizontal, that's going to be where D ends up. So you can place the point right there. And actually, let's go ahead and just get rid of that line. Place our point to give you point D. And now that you find that, we're able to find those distances that they ask for. So we can use the same strategy we used before of counting, or we can use the strategy of looking at the 2 points and determining what the like coordinates are. So point D, we would have to find the coordinates of, which would be 2, 4. Alright, so if we're finding the distance between A to D, again, we can count starting from A to the right. 1, 2, 3, 4, 5. Okay, so the distance from A to D is going to be 5. We can also add the coordinates that are different. So our coordinates that are the same in this case, we have 2, 4, which is D, and -3, 4, which is A. Here's D, here's A. Notice how your 4's are the same. That means we need to work with these other coordinates, 2 and -3. Add their absolute values. So just add them without negatives. 2 plus 3, and you see what you get. You get 5. So either way, we're finding the distance there of 5. And then they also want us to find the distance from A to B. So again, we can do that the same exact way. We can count down from A to B. 1, 2, 3, 4. Looks like 6. 1, 2, 3, 4, 5, 6. Yep, from one point to the next. Or we can go ahead and line up their points as well. A, again, is -3, 4. So that's A. And your B coordinate is -3, -2. So you can see that the like coordinates in this case are going to be your -3's. So we're not using those. We're actually using the other two coordinates, and we're going to add their absolute values again. And you can see when you add 4 plus 2, what do you get? 6. All right. So a couple more examples here. It says, given the following points, answer the questions. Which sides are vertical segments? Well, to do this, I would just quickly draw a coordinate plane, okay, and sketch out approximately where these points are. It's kind of like estimating. You don't have to be perfect here, but you can tell a lot by just sketching it out, and you'll be able to easily answer the questions. Which sides are vertical segments? Well, vertical, again, means running up and down. So we're going to plot the points, 5, 3. So 5, 3, and again, you don't have to notch out. You don't have to do all these notches. That's not necessary. Based on coordinates alone, we can pretty much determine approximately where these points are. So 5, 3 is going to be to the right 5 and up 3. So it should be right about there somewhere. The point -3, -1. We're going to go left 3 and down 1. So it should be approximately right there. 5, -1 means to go right 5 and down 1. So it's going to be approximately right there. And then D, and let me go back and label these real quick so we don't get lost here. That was A, B, C, and then point D, -3, 3. So left 3, up 3, which puts you about right there. So again, the reason why you do that, and make sure to label them, don't forget to label them like I did. The reason why you do that now is now you can tell which segments would be your vertical. So which ones are running up and down. And you just quickly sketched it, and you can see that A and C run up and down, and segment D and B run up and down. Okay, and it does have to do with like coordinates, just as we were talking about before. You can see how A and C have the same 5 as their coordinate. The X coordinate gives away if they're vertical or not. But I think for most students, it's a lot easier to just quickly sketch it out so you don't make a mistake with that. All right, how long are the horizontal segments? So again, it's asking for a distance here. Well, our horizontal segments, since we only sketched this out, we have to use our other strategy. Our horizontal segments would be B to C and D to A. So we really only need to find one of them. So let's just do D to A. So our coordinate our coordinate A is 5, 3, and our coordinate D is -3, 3. So which of those coordinates are alike? Well, the Y coordinates. So again, we don't use those. We're only going to use the X's in this case, and we're going, since they're in opposite quadrants, you can see D is in 2, A is in 1. We're going to add those, 5 plus 3. Ignore the negative. And you can see that the distance in this case is going to be 8. How long are the vertical segments? We'll do the same thing. We'll take, let's do D and B. Coordinate D is -3, 3. Coordinate B is -3, 1. Okay, which of those coordinates is alike? Are they in the same quadrant? No. The like coordinates are -3. So we're going to add I think I put 1 there. Yes, I'm sorry. We're going to add the Y coordinates in this case, which is 3 and 1, and you'll see that you're going to get 4. All right. Okay, so the next example then is going to be similar. It's just the same type of example. We're going to quickly sketch this out and to figure out which segments now would be parallel. You can see they're going to give you similar examples. They're just going to change the questions around. So we can use our same strategy here, though. We're going to sketch out a coordinate plane really quickly. And we're going to start with A. -1, 1 would put you left 1 and up 1, so that's about right there. 1, 1 is B, so we're going to go right 1 and up 1. About right there. And 2, 3 means to go right 2. I'm going to have to move my B. We're going to go right 2 and up 3. So that puts you about right there. So that's your C. And then -2, 3 puts you left 2 and up 3, which will put you right about here for D. All right. So again, we have what appears to be some type of trapezoid. It's kind of upside down from what you're used to seeing. And they want to know which of the segments are parallel. Well, again, you have to know what parallel means. That means that would run like a railroad track, never intersect. So it looks as though D to C and A to B. Okay, and again, because it's a sketch, you do have to be fairly accurate to a point. But because it's a sketch, you hopefully can see that the top segment D to C and A to B would run parallel. How long is segment A to B? Well, segment A to B would be -1, 1. and positive 1, 1. And you can see that the like coordinates here are your y coordinates, so you can ignore those and add the absolute values, so it looks like they're going to be 2 places away, which we should have known. One was negative 1, 1, one was 1, 1. So 1 plus 1 is going to make our answer 2. And then how long is segment C to D? So again, you have 2, 3 and negative 2, 3. So they're in different quadrants, so we're going to do the same thing. We're going to add the like coordinates here are the 3's, ignore those, and add your 2's. So 2 plus 2 is going to give you 4. Alright, this has been a quick tutorial on working with polygons in the coordinate plane. Thank you for joining me.